Hi, I'm Randall Heyman. Welcome to my 163rd Corona Help video. If you'd like me to make a video for you, then comment below any of my videos or drop me an email. So today I'm doing a video for Lucky Jinx. He watched my video, Truth Tables Made Easy, which I made many years ago before the virus. And he's got a question about the truth tables that I did in that video. Let me just actually write up what it's called, the video, just in case you want to go back and have a look. Truth tables made easy. Okay, so in the truth table, we have this situation here where P is false, Q is true, and then under the column P implies Q, we put true. And that seemed to be a bit difficult for Lucky Jinx to understand. And to be fair, many people have trouble with this. This is a difficult concept. We say that this is true here. We actually sometimes say that it's vacuously true. Or we might say that it's true by default. Okay, so, but nonetheless, it is true. So this, we would say, is the correct thing to put in the truth table. Okay, so how do we proceed? Well, if you're new to this, have a look at my video, Truth Tables Made Easy. I try and explain this by way of red ribbons and blue leaves and things like that. So here, what I'll do here is I'll take a slightly more formal approach. Maybe that will help Lucky Jinx and anyone else that's watching this. Okay, so let's just start off with, when we write P implies Q, what we means the statement, if P is true, then Q is true. Now this begs the question, what is a statement? So definition. A statement is a sentence that is true or false, and I'll just put here, but not both or anything else. Okay, so we have a very strict definition of what a statement is. Example, 1 + 1 = 2. That is a statement. What about 1 + 1 = 3? Well, that's a statement, that one, that's false. What about X is greater than 0? That is not a statement, because it could be both true and false. It depends what X is. If X is 1, it's true. If X is -1, it's false. Real life examples, I'll just say them. The temperature where I'm sitting right now is between 15 and 25 degrees Celsius. That is a statement, that is true, but the important thing is it's a statement. However, if I say the temperature where I am now is hot, well, we wouldn't consider that a statement, because hot's not really defined properly. Okay, so now this now loops back. I'll talk about it a little bit more about it in a sec, but it loops back to Lucky Jinx's problem back here, or actually here, because this statement can only be true or false. Now, Lucky Jinx might say, well, you should have a third thing, which is neither. So you either have a T for true, F for false, and N for neither. Now that conflicts this idea of a statement. So this is now, you could go down that path, but you are now, to some extent, undermining or redefining the basic foundations of maths. Now, there are mathematicians who spend time working on the foundational aspects of mathematics. For example, there are some mathematicians who don't recognize real numbers. If you went back in history, there were clearly times when people didn't understand, recognize, or work with negative numbers or complex numbers. So there's also some discussion about, I can't remember what it's called now, some paradox to do with sets, which sort of undermines in some ways the concept of sets. So you can read more about that if you want. I'm not going to discuss that, but I'm just saying we have to work within the foundations that we have for mathematics currently. Otherwise, we go off and work on a new foundation for mathematics. I mean, a lot of the benefits we get in society from mathematics come from having this structure. Okay, enough said on that. But to follow through this in a sort of some sort of logical fashion. Okay, definition. So I've already said that P implies Q. The statement is if P then Q. So the statement if P is true, then Q is false. Oh yeah, that's right. That's actually, if P is true, then Q is false. So this is important here. We define it when it's false and otherwise it's true. It's false when P is true and Q is false. Now that makes sense. Most people can get that, particularly if you've watched my video. My other video is false. Now, the important thing is this, otherwise, the statement is true. Okay, so now let's loop back up to here. So what I did in the video, Truth Tables Made Easy, is we went through this case and I explained here that we went through, it's fairly easy to show that this is not false, that the statement's not false. And so therefore it must be true because a statement can only either be true or false. So I hope that's helped Lucky Jinx. It's a difficult concept. If worst comes to worst, you may just have to sort of accept it as, you know, a foundational aspect of mathematics. If you like, it's one of the laws or rules of mathematics that we require if mathematics is to work in the way that we know it. And it may be the only way that maths can work. So I'll leave that with you. If you've got any more questions on this topic or any topic in mathematics, then comment me or email me. And if I think I can help you, I will.